Now let's consider the indeterminate case of 1 to infinity. Now notice, for this problem right here, for this limit, if we let x go to infinity, this inside just becomes 1 because this 1 over x goes to 0. And then, of course, as x goes to infinity, x is infinity, x goes to infinity. So you see this is a case of 1 to infinity. So how do we deal with that? Well, just let y equal this entire limit. Just let y equal x. The limit is x goes to infinity of 1 plus 1 over x to the x. Just let y be that. And then the reason we do that is because now we can take the log of both sides. So notice I'm just going to take the log of both sides. Instead of a log of the limit, I'll take a limit of the log. See, just writing it this way. Yeah, like that. Now the reason we do that is because now I can bring this x around front. See, one of the properties of log. So now I've got log y equals the limit as x goes to infinity of x log 1 plus 1 over x. Now we're almost ready to use LHopital's rule. Remember, we need a numerator and a denominator. So we're just going to use this trick where I can write this as the limit as x goes to infinity of log 1 plus 1 over x. And instead of multiplying by x, I'll divide by 1 over x. So that solves that problem of needing a denominator. So that's the little trick that we use. Now I can differentiate the top and the bottom. So I've got log y equals this. Now I apply LHopital's rule. So here we go. We've got ln y equals the limit as x goes to infinity. Now the derivative up top, I've got 1 over 1 plus 1 over x. See, that's the log part of it, right? We've got to use the chain rule. The derivative of the log, natural log, is 1 over whatever's in there, and then times the derivative of the inside. We have to use the chain rule. So the derivative of the inside is negative 1 over x squared. Now to see that, think about this. We have x to the negative 1, and if we differentiate that, we've got negative x to the negative 2. So that's where I got this, which is negative 1 over x squared. So that's where I got that. Now all that over the bottom, the derivative of the bottom, which is negative 1 over x squared. And you can see these divide out. So let's see where we are now. We've got the log y equals the limit as x goes to infinity of 1 over 1 plus 1 over x. Well, if x goes to infinity, that's just going to be 1, right? Because this part right here goes to 0. So now we have the log y equals 1. Now don't forget this part, because it's a common mistake. We would get here and say, we're done. Move on to the next problem. But no, we want the log. This is the limit of the log y. We want the limit of y. So what I need to do is I need to exponentiate. I need to apply base e to both sides, and we get y equals e to the first. So in other words, remember y was equal to this limit. Is equal to this limit. So we have this limit is equal to e. And that's how we can address limits of this form where we have an exponent. A lot of times that's what we'll want to do. We set y equal to the entire limit, and then we log it so that we can utilize that property of logs.